Let me show you how to develop event-based asynchronous communication between microservices using C# and Apache Kafka. In this tutorial, we'll cover how to run Apache Kafka, topic essentials and how to create a topic, the basics of message serialization, and of course, creating a producer for your microservices. This is a complete practical tutorial that will cover everything you need to build your microservice producer. Dear subscribers, this is a short announcement. Starting from this tutorial, I decided to write a code that requires some refactoring, and the purpose here is to engage you more to the development process. What you need to do, you just need to pull my branch, okay, and to refactor it and to push it to your remote repository and share the link below with me to your repository, and I will rate it out of 100 and will add my comments. So this is completely free. What are you waiting for? Let's get started. Before diving into details of Apache Kafka installation, topic creation, let's try to understand what is Apache Kafka and why Apache Kafka, why we need to use Apache Kafka in our microservice development. We are using Apache Kafka as a middleware between our microservices. So when you need to communicate between microservices to create asynchronous, loosely coupled communication between microservices, we are able to use Apache Kafka or it is alternatives, okay? For the Apache Kafka, let's try to understand first microservice communication. I have covered all the aspects of microservice communications with real-world examples in my microservice communication tutorial, and in this tutorial, we'll just cover a few things related to microservice communication to make a better understanding regarding to Apache Kafka. For the microservice communication, we have asynchronous and synchronous communication. When we use synchronous communication, it means our microservice A will wait a response from the microservice B to continue. In this case, you can compare it with simple methods communication. So you have two methods and one method calls another using a synchronous communication. In a synchronous manner, we will wait some response from the another method to continue. The same is applicable for our microservice development also. But on the other hand, when you use asynchronous communication between microservices, in the middle there is a message broker. You are sending requests not to directly microservice B, you are sending your data, you are producing a data to message broker. And we have other microservices that consume some data from message broker, okay? So microservice A acts as a producer and microservice B acts as a consumer in this case, and in the middle we have message broker. It helps us to create event-based asynchronous communication. It means our microservice A doesn't know about microservice B doesn't know about microservice A, and it is really easy for us to maintain, to extend, to change microservice A without affecting to microservice B. Same is applicable for microservice B also. This is the role of Apache Kafka when we develop our event-based asynchronous applications, okay? In the middle, we have Apache Kafka. This is our account microservice. This is our customer microservice, and account and customer microservices are producing some event that happened in the past. For example, account microservice will produce account created event and account number updated event. It doesn't matter. All the operations, all the changes in account microservice is going to be some event, and this event will be produced to Apache Kafka, and Apache Kafka will store this data as a binary, okay? And we have other microservices called, for example, report microservice or third-part service that will consume data from Apache Kafka. So Apache Kafka in the middle acts as a loosely coupled layer for our microservices, and it is possible for us to create event-based asynchronous loosely coupled communication between our microservices using Apache Kafka. Okay, now let's install our Apache Kafka. There are multiple ways of installing Apache Kafka, and we have a little bit differences per operating system when we install Apache Kafka, but the thing I'm going to show you is the universal one because we'll use Docker to install Apache Kafka. Before it, you need to install Docker Desktop to make sure that you have Docker Engine, Docker Server to interact with the Docker, and we will need some compose file here. This is about Docker compose file. I will add this file to the comment below for you to install it. There is nothing to do. You will just run Docker compose and that's all. But before it, let me show you what we have inside this Docker compose file. Why actually we use Docker compose? It is possible for us to interact with a single services without Docker compose, but when it comes to multiple services to run together to create some sort of infrastructure, we are using Docker Compose. Okay, for the services, Docker Compose consists from multiple services. These services are actually some executable files, just applications in our case. For example, right now we have three services in our Docker Compose file. This is our Zookeeper, Kafka, and Kafka UI. Okay, we will use Zookeeper, but the latest Apache Kafka version, especially starting from Kafka 4, it will be possible to exclude completely Zookeeper and to use craft mechanism for Apache Kafka. But right now, in most production-ready applications, they are using Zookeeper with Apache Kafka. So I decided to show you the Apache Kafka and Zookeeper combination together. What is a Zookeeper? Zookeeper is a manager over our Apache Kafka brokers. Okay, you can think about it like a manager that manages the broker information, that topic information, partition information. These are the terms that related to internals of Apache Kafka, but just try to understand that Zookeeper is a special manager that helps us to interact with Apache Kafka, that helps Apache Kafka brokers to be alive, helps acts as a notifier for your Apache Kafka. For example, when some brokers comes up, the Zookeeper notifies our Kafka when brokers goes down, when we create a topic, when we remove a topic, and also Zookeeper stores a lot of metadata information for your topics, partitions, etc. So it is important mechanism, and it is one part of Apache Kafka that's really important. But as I mentioned, starting from Apache Kafka 4, the Kafka team will completely deprecate Zookeeper. For the Apache Kafka, we have special image. For the services, for all services, we have image that we are going to download from the Docker Hub. Okay, we have internal and external port here. We have volume, environment variables. And for the Kafka 1, this is just the Kafka 1. It doesn't matter. You can rename it like you want. So we have image, we have port, so we'll access our Apache Kafka from the Docker using 9092 port. Okay, and we have some environment variables. Please don't change them. And at the end, Apache Kafka provides the CLI mechanism to interact with Kafka. So you need to write some command from the command line to make things really simple. There are UI Kafka applications, and one of them is our Kafka UI that helps us to do all important operations without interacting Kafka CLI. So we will use Kafka UI to interact with Apache Kafka. So the important services here is going to be our Zookeeper, Kafka, and Kafka UI. Let's install them, and for just copy this Docker Compose file to any folder you want. Right click, show more options. Let's open our git bash, and from the git bash or from the command line, it doesn't matter. You can do like this. Open your CMD, just copy this path. Okay, right click, type just cd, right click, paste, and this is our Docker folder, and you can just run docker compose up -d, and that's all. Hit enter, and let's go to our Docker desktop, and you see that we have these containers and images, all this stuff related to Docker. The important thing here is I already have these images, and for that reason, it took a few milliseconds for our Docker to realize that we already have these images. But when you are installing this Docker Compose file for the first time, it will take some time to download these images from the internet for you. Okay, so in my case, for the images, as you can see, I already have these images, and for the containers, it is really easy for a Docker to realize that we already have these images and run them. Now I have, let's just run this Kafka again, and that's all. And when you click to this Kafka UI, let's go for it, and you will see that we have this Kafka UI. We already have this broker information, we have topics, and all the things we need to start our development. Great, now it is time to learn everything in practice. For that purpose, I created a special branch here. It is tutorial microservice producer. Right now it is empty. We'll develop our application from scratch together. I will use Web API because we are actively using for microservice purposes Web API template. It will be a .NET 8 application with in-memory entity framework functionality. Okay, so let's right click, add new project here. We have from the templates, let's select ASP.NET Core Web API. Next, and this is going to be employee application API. Let's call it like this. Doesn't matter for us right now. Okay, let's hit next. Let's use .NET 8. You can use minimal API or just put the default controller, classical controller. It doesn't matter for us right now. Let's create the project. Okay, cool. For the development purpose, we'll create a simple in-memory database that contains only one table called employee. For that reason, I'm going to remove all this weathercast type of things, and I will add new folder. It is going to be our database. For the database, we're going to use in-memory entity framework. So let's install it. Install package Microsoft entity framework core in memory. Okay, let's hit enter. Cool, it is installed. You can just use the graphical interface of NuGet Package Manager. Okay, now we have a database. Let's go for the database folder, right click, class, employee, DB context. Okay, let's inherit from DB context here. Context, okay. And of course, let's create our constructor. Is going to be DB context options, employee DB context options. For the base, let's provide this DB context options. And of course, we need some DB set here, public DB set employees. Cool. Get turn and set turn. Okay, let's add another folder for our employee. It is going to be our models. Right click, add class employee. Okay, let's use record here. Public grid ID. Okay, we have the name, and of course we have surname here. Okay, I'm not going to add more properties here. The purpose here is not to develop a fully functional application. So purpose here is just to focus on producing some data. Okay, let's create our constructor. For the constructor, we are going to use grid ID string name, string surname. Cool. Let's for the ID. Let's just use the ID here. For the string, for the strings, we are using name to name, surname to surname. Great. Okay, what else we need here? Of course, we need to do some additional configuration around the DB context. Let's add our reference here. Cool. And let's go for the controller. I'm going to change the controller name to be employees controller. Okay. And let's just remove these summaries from here. Let's return our employee. And the name is going to be get employees. Right now, we can just exclude this naming stuff. Doesn't matter. Get employees. Okay, let's just put like this. And let's just inject our DB context, private, read only, our employee DB context, Okay, let's from the constructor add it, employee DB context, DB context, cool. DB context to DB context. Okay, and let's use our special primary constructor here. And for the logging purpose, let's do like log information, requesting all employees. Okay, and for the DB context, employees, let's to list asynchronously with await, and of course return them. Oops. Okay, so we have get employees information here to list asynchronously, and of course we need to wrap it to task like this. And let's check if our get employees is working. So debug, start without debugging. Right now we don't have any information, but I'm just checking if it is possible for us to send request and get some response, empty response. Okay, let's execute. So we have some issues here. The problem here is we haven't injected our DB context yet. Of course, let's inject it, go to the program of that controller. Let's add builder, services, add DB context, employee DB context, cool. And for the employee DB context, I need to provide some option here. Use in-memory database. Okay, for the in-memory database, let's use database like it is going to be employees DB, like that. Okay, debug, start without debugging. Let's try it again, execute. Cool, everything is working. So you see we got 200, means everything is okay. You may ask that, where is our service layer? Where is our repository stuff? So this is just simple application. Depending from your application requirement, application size, you may need to use service layer, repository layer. So we are not using them because our application is really simple. Don't over-engineer on your applications. Try to handle as much as possible with simple functionalities. Okay, so if you really need your service layer, then create them. If you really need repository abstraction, create them. But in my case, I don't need them. So for that reason, I'm directly using the DB context injection to my controller. Otherwise, in a classical manner, we'll have some service layers. The service layer will be wrapper over your repository plus business functionalities, etc. So we don't need them. We don't have any business logic here. Okay, and the other functionality here is going to be HTTP post public, and we are doing like this. This is also going to be our asynchronous operation. And let's go for task. I will return some employee information, post or create employee. For the employee, I will provide the string name, string surname. Okay. And let's create our employee, or employee equal to new employee. And let's provide new GUID, the name and surname. As I mentioned before, I'm going to write a code that requires some refactoring. So your task here is first try to refactor this functionality. Okay, add some validation. If you think you require a service layer, add a service layer. If you think you need some repository over your entity framework, the actual entity framework is also a repository pattern, but with unit of work. But if you think you need it, just add them. And let's continue for the DB context dot employees dot add. I will add this employee information and let's save changes. Okay, awaitable and return created at action. Let's use the current method name here with new ID equal to employee ID and the employee itself. So you see the create at action. This is our create at action result. So we have some action result here, of course. Let's see our save changes. Now what we need here doesn't get awaited. So the save changes, we don't have save changes asynchronous. Okay, let's use it. Let's just format it. And now let's debug, start without debugging. Cool, let's just check our employee. I'm just providing Simon Baker. Let's execute. So we have 201. It means data is created in our server. So let's check if we have this data. Let's execute. And here we are. We have Simon Baker. This is our simple web API with get all and create functionality. We have developed our simple web API, and now it is time to start to produce some data. But before that, we need to, in general, understand what type of components do we have in our Apache Kafka. We have producers, messages, brokers, cluster, and consumers. Okay, these producers here are going to be our microservices. So we have producer microservices. These consumers also going to be our microservices. So we also have consumer microservices. In this tutorial, we'll just focus on producing some data, and starting from the next tutorial, we will create our consumer to consume some data from the broker. Now we'll focus on creating a producer and producing some data. Okay, what is a producer? Producer is a responsible service that produce some data. Okay, you have some data and we call them messages. So we are producing some message, and Kafka broker acts as a storage, as a database for your messages. Okay, this is not a database. This is using a special log type of mechanism in a binary format, but in general, let's try to understand that we have some sort of database that stores these messages, okay? And this is our broker. As you remember before, we use a Docker Compose to install our Apache Kafka with one broker. Kafka UI and Zookeeper. So for the development purpose, it is completely okay to use one broker, but for the production purpose, we always have more than one broker. So what is a broker? Broker is just a server, but it is more than server, because in a Kafka broker, every broker knows about each other. Okay, so this broker, for example, this is broker 1, this is broker 2. Broker 1 knows all the information about broker 2, and broker 2 also knows about information for the broker 1. And Kafka cluster acts as a logical isolator over our brokers. This is really simple. In a classical development about 10-15 years ago, there was a web server, and as a developer, we have published our applications. We have published our applications to this server, but now we have more requirements, more user, more requests, and for that reason, one server is not enough, and we just renamed the server to the broker, okay? And now we have multiple servers to handle these queries, okay? And they are together, acts as a cluster. And on the other hand, we have consumers. They are also microservices, and in the middle we have Kafka cluster that consists from multiple brokers. It means this acts as a logical isolator. Now our producer doesn't know about consumer, our consumer doesn't know about producer, but producer is able to produce data and consumer is able to consume data. Okay, that's brief all about Apache Kafka. But if you want to learn more about Apache Kafka, if you want to learn it from A to Z to master it, I have Apache Kafka for distributed systems on Udemy. This is a video course that contains all the information you need to master Apache Kafka from scratch. So you can check this course and learn everything about Apache Kafka. Okay, now let's start to inject our Apache Kafka to our web API. For that reason, I am just going to Tools, NuGet Package Manager console, and from the Package Manager console, let's just type install package confluent.kafka. Okay, let's hit enter. This is going to be our main library to work, okay? And cool, now we have Apache Kafka. Okay, and what I'm going to do to create a producer, I need to produce some data, and my create employee allows me to produce a data. When I create some data, when I update some data, when I delete some data, I want to notify my subscribers, other microservices, about the event happened right now in my current microservice. That's called simply event or message. Okay, after saving some information, I am going to create a message to produce to Apache Kafka. For that reason, var message create equal to message. In our Confluent Kafka, we have special class called message, and this is a generic class that requires two type definition here, one for key and another one for value. Our messages at least consist from key and value. Key is optional, but value is mandatory. You need to provide some value of your message. You can think about it like key value combination in our dictionary. Okay, so for the message we have some sort of key and value. The key defines how we are planning to consume this data. This is a little bit advanced topic, but just understand that depending from your Apache Kafka configuration, it is possible for your consumers to consume the same key from one consumer or the different keys from the different consumer side. So if you want your consumer, for example, you have consumer A, if you want your consumer A to consume the same messages in an ordered manner, you may use keys here. But if you don't want to consume some ordering mechanisms from your consumer's perspective, then it is completely okay for you to just provide ignoring information here in your keys. But for my keys, I am going to use some sort of grid information and also some sort of value here. For the value, I'm going to use string. I will produce some string, but you may think that I have employee information and this employee is not a string but a composite type. Of course, yes, but we have two options here. We can implement our own serialization mechanism or use built-in Confluent serialization mechanism, or just simply serialize our data using system text JSON to string and produce it as a string, but it contains a huge JSON object. Okay, I will use this mechanism here. For the message, let's provide our key. So my key is going to be employee ID and my value is going to be JSON serializer dot serialize, and let's serialize our employee. Okay, I've serialized this employee. Now let's see, this is a string, so it is completely okay. Let's just format it. Now we have a simple message to produce, and now it is time to configure our producer and start producing process. It doesn't matter if you are developing your producer or your consumer, they are together called client. Okay, your producer and your consumer, they are clients. And for the producer, you may realize that let's create first our producer config. Okay, for the producer config, we have special class called producer config that has three constructors, one for default constructor, the other one that works with client config, and dictionary string. It means for the client config, if you have same sort of configuration for your producer and consumer, and if you don't want to type the same sort of configuration for your producer and consumer, you can just simply use client config here. But I will just use the simple constructor. We have mandatory argument called bootstrap server. This is the exact requirement to connect to our Apache Kafka. Let's check it for the Docker desktop. We have Kafka 1.1 and it is 9092. Okay, and let's define it localhost 9092. Okay, where you want to produce, where is your Kafka broker? Okay, you may have multiple brokers, but the broker is more than server. We talked about it, and in this case it is just enough to define only one broker's address here, because one connecting to one broker means connecting to whole cluster in Apache Kafka. So if you have localhost 9092 and 9093, you have two brokers. You may just connect to one broker. It means you are connected to whole broker. You are able to communicate with localhost 9092 and 9093. Okay, and let's add some additional configurations here. I want to get acknowledgement from all my servers. Let's short talk about the acknowledgement process. It is possible for us to have multiple backups for our message. For example, you are producing data to broker 1. Okay, this is our broker 1. And we have also broker 2, which acts as a reserve. We are calling it in sync replica. Okay, in sync replica. So broker 1 will replicate your message to broker 2. And when broker 1 fails, your system will able to continue to work because you have the same message in your broker 2. When you configure acknowledgement to none, it means you are sending data to your broker and you are not waiting response from your broker. You don't care that it is okay to your broker to get it or there was some error. This is not a good option. You can use acknowledgement.leader. It means, for example, in my case, broker 1 acts as a leader and I am producing some data and I just want to get information from broker 1. I don't care if it is replicated or not. But when you use acknowledgement all, it means you're producing data your leader broker will get this data, will replicate this data, and you will get response that everything is okay. Otherwise, for example, your broker 1 got your data but replicating fails, then you will get error and the process will fail. Okay, it is better to use acknowledgement all with min in sync replica configuration, but this is an Apache Kafka details. Just check my course to the whole information about Apache Kafka and master it. Okay, 2 properties here I think are enough for us, and now let's build our producer. For producer, we are using producer builder to create our producer. Same is applicable for consumer. We'll use consumer builder. For the producer builder, we need to specify same sort of configuration here. Okay, so if you have message queue string, you need to provide producer builder queue string. Okay, and you need to specify your producer config with build method. It means now we have a producer, okay, and we are able to produce data. To produce data, you need to use produce asynchronously or produce depending from your requirements. If you really want asynchronous communication, the fast without ordering, just use produce asynchronously. The produce asynchronously first requires a topic to produce a data. We'll talk about this topic. Let's just provide our message, and that's actually all. Let's not wait, just call waitable here. And for the producer, we of course have the closing mechanism, disposing. Okay. As you can see, here we have a lot of information that needs to be refactored. For example, some tricks for you. Add this information to the configuration, reading this information from configuration, inject your producer, encapsulate this mechanism to another class to provide less information for your controller, because your controller's responsibility is not configuring your producer, is not configuring your producer config, is not configuring your producer. So you should take care of that. Okay. Now let's talk about learn about the topic itself. So before producing some data, we need to learn where to produce. Okay, you have a broker. Okay, this is our broker. Broker acts like a database. Okay, I have a database. Okay, I am connecting to the database, but to write a data, to read a data, I need a table. Okay. Connecting to database is not enough. There should be some table to read and write. And topic acts as a virtual table. Okay, topic is a virtual table in our Apache Kafka. Let's talk about it. So what is a topic? Before producing a data, we need to create a topic. Topic is a logical container of data streams. So in SQL, we have rows, but in Apache Kafka, we have data streams. And this acts as a logical container over our data streams. So topic is a stream of data that acts as a logical isolator over partitions. You may think that in Apache Kafka we have a table, one table, but there isn't a table. And topic is just a logical container. Behind the scenes, we have partitions, not topics, and one topic can mostly consists from multiple partitions. The purpose here is distribution. If you store your topic in one broker and this broker fails, it means you will lost all the data. But when you have table separated in your brokers, it means when one broker fails, your application will be able to continue to work. That's why we have partitions. Behind the scenes, we have partitions. But as a user, we interact mostly with topic. And topic spread out between brokers. We talked about it. It means every broker consists contains only part of the topic. Topics are replicated across multiple brokers for fault tolerance and scalability. So, as a long story short, you have a topic that consists from multiple partitions. And when you have multiple brokers, in my case, I have two brokers, you say that first part of topic A will be stored in this broker. The other part of this topic A will be stored in broker 2. That's how Apache Kafka tries to spread your table between brokers, and this helps for fault tolerance and scalability. Okay, cool. Now let's switch to the development process. In our development, we need to specify our topic name. The best option here is before producing data, you need to configure your topic. Otherwise, it is possible for Apache Kafka to create a topic when directly producing. This is a bad habit. You need to specify some additional configuration for your topics to be read when the producer produces a data. The better option is to manually create a topic. Let's do it for the Kafka UI. From the Kafka UI, we'll do all the operations. It is okay to use Kafka UI, but if you want to master Apache Kafka, it has Kafka CLI that helps you to interact with Apache Kafka, and you can do everything using Kafka CLI. But we'll use right now the Kafka UI. For the Kafka UI, let me just remove the unused things here. I will create a new topic using a topic here, okay? And let's create employee topic. The number of partitions, this is really important. I will provide, let's say, 4. Right now, I have 1 broker, but it doesn't matter how many brokers do I have. The system will create more than 1 partitions for the topic. And if you have 1 broker, it will store all the partitions in 1 broker. Okay, and replication factor is going to be 1 because right now I have only 1 broker. If you have more than 1 broker, you can specify more than 1 for replication factor. This is also another huge topic. You can learn everything related to Apache Kafka. You can master it using my Apache Kafka for Distributed Systems Udemy course. Okay, let's just create it. Right now in our employee topic, think about it like a table. We have 0 messages. It means we have 0 rows. We don't have any information. Okay, cool. Now let's go for it. Let's specify employee topic here. It is better to move it to the configuration also. This is also one task for you to do. Cool. Let's remove unused stuff here, and let's just test if everything is working. I'm just running the web API. I will produce some data, okay, and check that if it is possible for us to send employee information as a message to our Kafka broker. Let's just test it. Okay, for testing purpose, let's execute. And we have value cannot be null, key serializer not specified. Yeah, cool. Let's go for it. Right now, we have GUID, and for the Apache Kafka, unfortunately, have only some built-in serializers, okay? When you are sending a message, your system is going to serialize your data because in Apache Kafka, we have only binary information, and your string needs to be serialized, your integer, GUID, all the information needs to be serialized, okay? For the string, we have default string serializer, built-in serializers. Let me show you. When before build, you can put set key serializer, and for the key serializer, you can specify serializers dot, for example, it uses by default serializers UTF-8 for string, for integer int 32, for long int 64, for double we have, byte array we have, and as you can see, we don't have have the GUID type of serialization. For that reason, what I am going to do, I'm just going to replace it with string, and yeah, just add to string. Otherwise, I need to write my own serializer. This is also not a complex task, but to make things really simple, let's just use the string mechanism here. I'm not going to use any key serializers because we already have a new specify string behind the scenes. Our Kafka will use string serializer. Cool. And let's provide string here. Let's go for employees post. Try to send Hanmabaki. Let's execute it. Let's wait for the response. Now we have a response. Cool. Let's check if it is stored in entity framework. Okay. Now let's go for the Kafka to check if we have a message here. Go to topics, go to employee topic. We have one message here. Go to messages. And as you see, we have key information and we have value information here. Well, that's almost all. In this tutorial, we talked about C# and Apache Kafka combination. We learned how to create a producer microservice. We learned about topics, about producer configuration, and also about Kafka itself. If you like my videos, please don't forget to subscribe, hit like button, add your comments. Let's be more engaged. Add your branch links to the video and I will check it. I will estimate it and I will help you to write better code and to learn everything about C# and Apache Kafka along with microservice development. See you in the next tutorials.